In this video, I'll show you how to work through trigonometry-related problems on your MCAT without a calculator. When you think of trigonometry, you're probably thinking Sohcahtoa, so let's see how that applies to the MCAT. Sohcahtoa breaks down as follows. We have sine, cosine, and tangent. Without going into too much boring trigonometry, let's see how to look at this triangle. When given some angle theta, you put this line to represent the angle in question. The two sides of the triangle that form a right angle. The adjacent is the side of the triangle that is near your angle. The opposite is the side of the triangle that doesn't touch your theta value but is still part of that 90-degree or right angle. And finally, the line that connects the adjacent and the opposite but is not part of that 90-degree, that is called your hypotenuse. We'll use Sohcahtoa to find sine, cosine, and tangent. Sine is opposite over hypotenuse, or typically this line over here. Cosine is adjacent over hypotenuse and is referring to this line over here, and tangent is simply the opposite over the adjacent. If you learned trigonometry, you worked on many different angles and set them up in many different ways. But on the MCAT, the majority of triangles that show up will be set up like you see this one, where the sine refers to your y value, and so we'll write it as syn to remind you that sine is y. Your cosine typically refers to your x value, and so we'll add an x at the end to remind you that cosine refers to x. And since tangent is opposite over adjacent, tangent is simply going to be y over x. Now I say the majority of the time, if you're dealing with an inclined plane, you'll find that your coordinates change. But if you're dealing with any physics, kinematic type problems, you're okay to use sine y and cosine x. Before we can go into a math problem, we have to know how to calculate the sine, cosine, and tangent values without using a calculator. Since tangent is y over x, that's simple division and we won't look at that. Instead, I want to focus on the values for sine and cosine as you want to think about them on the MCAT. For example, you may get a question that asks you to calculate the sine value or cosine value of 45 degrees. But if you think the cosine of 45 is rad 2 over 2, that may be correct in a trigonometry class, but how are you going to do that on the MCAT? No. What you need to know is a simple, rounded number that you can easily use in calculations to help you quickly work through the math and come up with the correct answer. I'm going to show you the proper values for sine and cosine, but I also want to show you a trick and a shortcut to help you quickly come up with the numbers even if you get stuck or even if you panic. We'll look at this simple coordinate system where we have 0 degrees to the right, 90 degrees above, and simply work our way around. We have 180 degrees left and 270 on the bottom. I want you to imagine that starting from the origin, I draw a line that has a unit length of 1. Remember the trick. We spelled sine with a y and cosine with an x. This is to help you quickly identify your sine and cosine values. In fact, let's create a table and match the trick to the values on the table. We have the table. Now let's see how this diagram will help us come up with the values. If this line with a unit length of 1 is sitting parallel to the x-axis at 0 degrees, the cosine, or the x value, is 1. Because the line has a length of 1, a height of 0, so the x value, or the length of 1, gives us a cosine of 1 for 0 degrees, and sine of 0 for 0 degrees because we haven't raised it anywhere in the y direction. Keep in mind this is not drawn to scale, but imagine that I now raise this line to 30 degrees. If drawn to scale, the tip of that ray will be halfway up between x and y, and that means the sine value of 30 degrees is half, or 0.5. The cosine value on a calculator comes to 0.866, but on the MCAT you can get away with using 0.9. Now you can memorize 0.866, but this trick will be easier if you recognize that 0.866 is very close to 0.9, and that on the MCAT, when you round, your answer will typically be close enough. If we raise that line to 45 degrees, notice that our cosine value keeps getting smaller and smaller. Here we're at 1, here we're at 0.9. Here we get to something that the calculator will call 0.707, but for the sake of memorization, we'll just keep it at 0.7. The sine value or the y value has gone from 0 to 0.5, and now we're slightly higher at 0.707, which once again is rounded to 0.7. Let's take this ray and raise it up even more, moving up to 60 degrees. Notice that the x value is halfway between the origin and a length of 1, giving me a cosine value of 0.5. The sine value, on the other hand, is getting higher and higher and is nearly at the top for a calculated value of 0.866 and a rounded value of 0.9. If we turn our ray even more and make it parallel to the y-axis pointing directly at 90 degrees, notice that we have nothing in the x direction because the ray is sitting on that y-axis, giving me a cosine value of 0, but because the ray is a length of 1, pointing straight up at 90 degrees, we get a sine value of 1. Now that we have our numbers, I want you to notice this pattern. Starting from cosine 0 degrees, we have 1, and then we drop by 0.2, 0.9, 0.7, 0.5. Once we're at 0.5, we drop to 0. For sine, we have the exact opposite pattern because we're starting at 0, we jump to 0.5, and then increase 0.7, 0.9, 1. So on your MCAT, yes, you can use 0.707 or 0.866 if you have to, but if you want to have that ballpark first to figure out where to start with your angles, draw the quick sketch with a 0 for cosine and then just write 1, 0.9, 0.7, 0.5, and figure out where you stand based on the angle that you're given. These are the main angles that I want you to memorize, but you can always infer in between angles based on what we have here. So for example, if your MCAT question asks you to calculate something related to 37 degrees, 37 is partway between 30 and 45. So the sine value will be something near 0.6, the cosine value will be something near 0.8, and you can apply this everywhere. I'm also including 180 degrees in this trick to remind you that if you pass the 90-degree mark, you're going into the negative x territory, which means all the values will be the same, except that the cosine of 180 will be 1 in the opposite direction, or -1, and sine, of course, will still be 0. Let's apply this to a problem that may show up on your MCAT. A child pulls on a 4-kilogram wagon with a force of 9 newtons. Find the initial acceleration of the wagon if the force is applied at a 30-degree angle to the ground. The physics portion of this question will be tackled in the physics videos found at leahfisch.com/MCATphysics. But because I want to focus on math, I'll jump straight into the equation. If we have force is equal to mass times acceleration and we want to solve for acceleration, we divide by mass, giving me the formula acceleration is equal to force over mass. But we can't use the total force, we can only use the force applied to the direction of motion. I'll simplify the wagon as a rectangle. Here we have the child pulling on the wagon with an angle of 30 degrees to the ground. If the force of 9 newtons is applied 30 degrees, we only want the component in the x direction since the acceleration will be in the x direction. That means we have to take the initial force and break it into its x and y components to know what to use in this situation. Force in the x direction equals force times the cosine of 30 degrees. How did I know to use cosine? Remember the trick. We're spelling cos with an x, reminding us that the standard triangle uses cosine for the x value. Cosine of 30, according to our shortcut, is 0.9. We're not going to use 0.866 because the math will take too long. So we have 9 newtons times cosine of 30, which is 0.9. 9 times 9 is 81, but because the decimal is 1 space to the left, we move the decimal back 1 space to the left in our answer 2, giving us 8.1. To solve for acceleration, we plug in the value for force, 8.1 newtons, the value for mass, 4 kilograms. We'll round 8.1 to 8, and so 8 divided by 4 equals 2, and the units for acceleration are meters per second squared. Be sure to join me in the next video where I show you how to solve logs without a calculator, as it'll show up in pH, pKa, and similar type questions. MCATexamstrategy.com